Please remember Intel 4004 PMOS 4-bit 640 bytes memory capacity. Intel 8008 word length is 8-bit, memory capacity 16 KB. Intel 8080 NMOS word length 8-bit, memory capacity 64 KB. Intel 8085 NMOS, very important, word length 8-bit, memory capacity is 64 KB. Intel 8086 HMOS word length 16-bit, memory capacity 1 MB. Intel 8088 word length 8 or 16-bit, memory capacity 1 MB. Intel 80186 word length 16-bit, memory capacity 1 MB. Intel 80286 word length 16-bit, memory capacity 16 MB, real 4 GB virtual. Intel 80386 word length 32-bit, memory capacity 4 GB, real 4 GB virtual. Intel 4048 80486 32-bit word length, memory capacity 4 GB, real 64 TB virtual. Pentium 2 word length 64-bit, memory capacity 64 GB real. Microprocessor 7Z80 word length 8-bit, memory capacity 64 KB. Microprocessor 7Z bar 800 word length 8-bit, memory capacity 500 KB. Mnemonic, a combination of letters to suggest the operation of an instruction. Program is a set of instructions written in a specific sequence for the computer to accomplish a given task. Machine language is a set of instructions executed directly by computer's CPU. Assembly language, it is a low-level programming language in which there is a strong correspondence between the language and the architecture's machine's core instructions. Low-level language, machines specific languages are known as low-level language. Example: machine language, assembly language. High-level language, a programming language that enables a programmer to write programs that are independent of particular type of computer. Assembler, it is a computer program that translates an assembly language program from mnemonics to the binary machine code of a computer. Compiler, a program that translates high level language program into machine level language by translating the entire program at a time and executing it. Interpreter, it translates high level language program in object codes statement wise. High-level language programming requires a translator like a compiler or an interpreter to translate the program written in high-level language to binary form. Bit, a binary digit 0 or 1. Nibble, a group of 4 bits. Byte, a group of 8 bits. Word, a group of byte the computer recognizes and processes at a time. Architecture of 8085. There are two types of architecture depending upon storage of program and data in memory. One human architecture, both data and program are in the same memory. Intel 8085, Intel 8086. Harvard architecture, program and data are in different memories. TMS 32010, Intel 8051, example Intel Pentiums, etc. Pin configuration. Remember X1, X2, reset out, SOD, SAD, trap, RST 7.5, RST 6.5, RST 5.5, INTR, INTA, whole bar, AD0 to AD7, VSS, VCC, whole, HLDA, clock, reset in ready, IO, S1, RD bar, WR bar, ALE, S0, A15 to A8. Key features of 8085 microprocessor. It is a 8-bit microprocessor. It has 8 data bus lines, which is the bit capacity of the microprocessor. It has total 16 address lines with addressing capacity of 64 KB. The crystal frequency of processor is 6 MHz. The clock frequency is 3.07 MHz, which is approximately half the crystal frequency. Low order address bus AD0 to AD7 is multiplexed the data bus in order to reduce the number of pins. Low order address bus AD0 to AD7 is multiplexed with data bus in order to reduce the number of pins. To demultiplex address from data, ALE address latch enable signal is used. ALE equal to 1, address transfer to bus. ALE equal to 0, data transfer to bus. Disadvantage of multiplexing is that speed will be reduced. There are 5 hardware interrupts available for 8085. 8085 has 74 basic instructions with 246 opcodes. Power supply signals, VCC, VSS, clock signals, X1, X2, clock out, reset signals, reset in, reset out, interrupt signals, trap, restart interrupts, RST 7.5, RST 6.5, RST 5.5, intra, INTA, INTR, INTA, address bus and data bus. Address bus means A8 to A15 multiplexed address data bus, AD0 to AD7 status signals and control signals. Status signals and control signals address latch enable is available in status signals and control signals. Input output memory is also available. Status signals S1 and S not available. Read bar and write bar ready also available. Serial input output signals HOLD, HLDA, DMA request signals, SID serial input data, SOD serial output data. System bus. Bus is a group of wires or conductors used for communication between processor, memory, and input-output device. Address bus. It is used to transfer address of memory or input-output from the processor. It is unidirectional. Address bus defines maximum memory that can be connected to a processor related by 2 power n equal capital N, where n equal number of address lines, capital N equal number of address or memory locations. Data bus. It is used to transfer data between processor, memory, or peripheral devices. It is bidirectional. In 8085, it is multiplexed with lower order address bus. ALE1 equal to all lines are address bus. ALE0, A15 to A8 address bus. AD7 to AD0 data bus. Control bus. This group of control signals required for various operations of the processor. It is considered to the unidirectional if signals from processor are considered. It is partially unidirectional and bidirectional if the control signals are considered. Control and status signals RD bar. Read when the signals is low on this pin, the microprocessor performs memory reading or input output reading operation. Write WR bar. Write when the signal is low on this pin, the microprocessor performs memory writing or input output writing operation. IO bar M bar. This data signal is used to give information for operation to be performed with memory or input output device. IO bar M bar, RD bar, WR bar description. IO bar M bar 0, RD bar 0, WR bar 1 అయితే memory read MEM or whole bar. అలా కాకుండా IO బార్ M బార్ 1, RD బార్ 1, WR బార్ 1 అయితే memory write MEMW whole bar. అదే IO బార్ M బార్ 1, RD బార్ 10, WR బార్ 1, 101. IO read IOR bar. IO bar M bar 1, RD bar 1, WR bar 0, IO write IO W bar. S1 and S0, these status signals are used to indicate the status of operation. S1 S0 00 అయితే halt, no operation. S1 is 0, S0 is 1, write operation. S1 is 1, S0 is 0, read operation. S1 and 1, S0 1, opcode fetch reading instruction. Power supply and frequency signal. VCC power supply pin of plus 5 volts. X1 and X2. A crystal is connected across these pins. The frequency is internally divided by 2. Clock out. This pin, there will be a synchronization between the different peripherals and the microprocessor. Serial input output. SID serial input output data. This pin is used for receiving the data into microprocessor serially. Serial output data. This pin is used for sending the data from the microprocessor serially. Externally initiated signals, hardware interrupts, trap, RST 7.5, RST 6.5, RST 5.5, INTR are called hardware interrupts. Is also used to accept external interrupts to provide acknowledgement to the external device. Remember, in priority order, interrupts are as trap has highest priority, greater than RST 7.5, greater than RST 6.5, greater than RST 5.5, and INTR has the least priority. Remember, ready is used to interface with the slow peripheral devices, memory or input output devices to the microprocessor. Reset. Reset in whole bar. It is an active low signal. When the signal gets activated, microprocessor is reset. Reset out. This signal is out to reset the other peripheral devices. Hold and HLDA. Hold. A peripheral like DMA controller sends the hold request to the microprocessor through this pin to leave the data bus which is being used the microprocessor. HLDA. Hold acknowledge. Internal architecture of 8085 microprocessor. It contains of so many things what we will discuss. The architecture is divided into following functional units: arithmetic and logical unit. The ALU performs arithmetical and logical operations. The arithmetic ALU performs arithmetical and logical operations. It includes accumulator. It is a 8-bit programmable register. All the arithmetic and logical operations performed with contents of accumulator. The results are stored in accumulator only. Temporary register. It is an 8-bit non-programmable register used to hold data during an arithmetic and logical operations. Arithmetic and logic circuits. This unit performs the actual numerical and logical operation flags. The flags generally reflect the status of arithmetic or logical operations. D7 yes, D6 Z, D5 nothing, D4 AC, D3 nothing, D2 P, D1 nothing, D0 CY. Carry flag CY. If an arithmetic operation results in a carry, the carry flag is set, otherwise it is reset. Parity flag. If the result has an even number of ones, the flag is set. If the result has an odd number of ones, the flag is reset. Auxiliary carry AC. It is an arithmetic operation. If carry is generated by bit D3 and passed it to D4, flag is set. Otherwise, it is reset. Zero flag Z. Zero flag is set to 1 when the result is 0. Otherwise, it is reset. Signal flag S. Signal flag is set to if bit D7 of the result is 1. Otherwise, it is reset. Among the five flags, the AC flags is used internally for BCD arithmetic. The instruction sets does not include any conditional jump instructions based on the AC flag. Cross is the flag register indicate the unused flip-flops. The values of D1, D3 and D5 bits should be taken as 0 in programs while using PSW instructions. Register array. The architecture of 8085 consists of following registers: temporary registers, temporary data registers. It is also called as operand registers. 8-bit. It provides operands to the ALU. Temporary registers W and Z. These registers are not available to the user. W and Z registers are used by 8085 for swap instruction. General purpose registers. The 8085 microprocessor consists of 6 general purpose registers, that is B, C, D, E, H and L of 8 bit each. Registers are available to the user. General purpose registers puts together is called scratch and memory. The valid register pairs available are BC, DE, HL to store 16-bit of data. The HL register pair functions as a default data pointer. It is used as memory pointer. It holds the address of a 16-bit address at a memory location. Accumulator can also be used along with status registers to form a 16-bit programmable register called program status word PSW. Special purpose registers. There are 16-bit special purpose registers, that is program counter PC and stack pointer SP. Program counter, it is a 16-bit register used to hold memory addresses. Stack pointer, it is a 16-bit register used as memory pointer. When the microprocessor is reset, the PC sets to 0. Stack grows from bottom to top following last in first out LIFO structure. The SP content keeps decreasing as stack grows. Timing and control unit. It controls all internal and external circuits in the microprocessor system. The microprocessor used as quartz crystal, LC or RC circuits to determine the clock frequency so that the timing and control signals are developed. Instruction register and decoder is a part of ALU. Instruction register. The instruction register holds the opcode of the instruction that is decoded and executed. Instruction decoder. The output of the instruction register connected to the decoder. The decoder decodes the instruction and establishes the sequence of events to follow. Interrupt control unit ICU. Interrupt control unit's job is to service the interrupt, and after completing the interrupt service routine, return back to the control to the main control where it was interrupted. Instruction set and data formats. Timing diagram. Instruction cycle. The CPU fetches one instruction from the memory at a time and executes it. One instruction cycle consists of 1 to 6 machine cycles. Instruction cycle consists of a fetch cycle and execute cycle. Machine cycle, the time required by the microprocessor to complete the operation of accessing memory or input-output device is called as a machine cycle. One machine cycle can contains of 3 to 6 T states. Instruction cycle consists of several machine cycles. Different types of machine cycles are opcode fetch 40 to 60, memory read 3T, memory write 3T, input output read 3T, input output write 3T, INTR acknowledgement and bus idle 3T. T states. Microprocessor performs an operation in a specific time period, that is a specific clock cycles. Each clock cycle is called as a T state. IC instruction cycle MC1, MC2, MC3, MC4, MC5. For MC1 equal to T2, T2, T3, T4, T5, 6. In MC1 there are T1 to T6. Classification of instruction set of 8085 microprocessor. Instruction set based on length of word size: 1 byte, 2 byte, 3 byte. Based on addressing modes. Direct, register, register indirect, immediate, implicit or implied. Based on operations, data transfer, arithmetic, logical, branch control, stack, input output, and machine control. Instruction is a binary pattern designed inside a microprocessor to perform a specific function based on length of word size. One byte instruction. The one byte instructions specify the operations to be performed and who is going to perform it. These instructions require single memory location, 2 byte instructions. The 2 byte instructions uses first byte to specify the operation, that is opcode, and second byte to specify the operand. These instructions require two successive memory locations in the memory. 3 byte instructions, the first byte stores opcode, second byte stores lower order 8 bit of 16-bit operator operand or address, third byte stores higher order 8 bit of 16-bit operand or address. Based on addressing modes, register addressing mode, register addressing mode, the source and destination are general purpose registers. Immediate addressing mode, in immediate addressing mode, the data 8 bar 16 bit is specified in the instruction itself. Direct addressing mode, in direct addressing mode, 16 bit the address of the operand is given within the instructions itself. In indirect addressing mode, the instructions reference the memory through a register pair, that is the memory address where the operand is located is specified by the contents of a register pair. Implicit addressing mode, the implicit addressing mode of addressing does not have require any operand, the or data is specified within the opcode itself. Based on operations, abbreviation used in the description of the instruction set: or equal register, rd register destination, RP register pair, XX random information, Z 0 flag, P parity flag, RS register source, M memory brackets contents, S sign flag, AC auxiliary carry flag, CY carry flag. Data transfer instruction: move copy from source to destination, opcode move operand, RD bar M, RS bar M, bytes 1, M cycles 1 by 2, T states 40 bar 70. This move copy, this instruction copies the contents of the source register into the destination register. The contents of the source registers are not altered. Move RD, RS requires 1 M cycle and 40. Move RD, M and move M, RS requires 2 M cycle and 70. MVI move immediate to 8 bit. MVI operand R bar M, 8 bit data bytes 2 M cycles 2 bar 3 cycles. T states 70 bar 10T. Description: the 8 bit data are stored in the destination register or memory. LXI load register page immediate. LXI opcode operand RP, 16 bit data bytes 3 M cycles 3, T states 10T. Description: the instruction loads 16-bit data in the register page designated in the operand. This is the only instruction that can directly load a 16-bit address in the stack point register. Remember, LXI, LDA load accumulator direct. LDA 16-bit address bytes 3 M cycles 4, T states 13T. The contents of the memory location specified by a 16-bit address in the operand are copied to the accumulator. The contents of the source are not altered. STA store accumulator direct. STA opcode operand 16-bit address bytes 3 M cycles 4, T states 13T. Description: the contents of the accumulator are copied to a memory location specified by the operand. LHLD load H&L registers direct. Opcode LHLD operand 16-bit address bytes 3 M cycles 5, T states 16T. Description: the instruction copies the contents of the memory location pointed out by the 16-bit address in register L and copies the contents of the next memory location in register H. SHLD, that means store HNL registers direct. Opcode SHLD operand 16-bit address bytes 3 M cycles 5, T states 16T. Description: the contents of register L are stored in the memory location specified by the 16-bit address in the operand, and the contents of H register are stored in the next memory location by incrementing the operand. The contents of register HL are not altered. LDAX load accumulator indirect. Operand RP opcode LDAX bytes 1 M cycles T states 70. The contents of the design register pair point to memory location. This instruction copies the contents of that memory location into the accumulator. No flags are affected. STAX store accumulator indirect. Opcode STAX operand RP bytes 1 M cycles 2 T states 70. Description: the contents of the accumulator are copied into the memory location specified by the contents of the operand register pair. Flags, no flags are affected. XCHG exchange H and L with D and E. Opcode XCHG operand none bytes 1 M cycles 1 T states 4T. Description: the contents of register H are exchanged with the contents of register D, and the contents of register L are exchanged with the contents of register E. Arithmetic instructions: add register to accumulator. Opcode add operand R bar M bytes 1 M cycles 1 by 2 T states 4 T bar 70. Description: the contents of the operand register memory are added to the contents of the accumulator. Result is stored in the accumulator. ADC add register to accumulator with carry. ADC R bar M bytes 1 M cycles 1 bar 2 T states 4 T bar 70. Description: the contents of the operand and the carry flag are added to the contents of the accumulator, and the result is placed in the accumulator. Add immediate to accumulator ACI with carry. Add immediate to accumulator with carry. ACI operand 8-bit data bytes 2 M cycles 2 T states 7. Description: the 8-bit data operand and the carry flag are added to the contents of the accumulator. The result is stored in the accumulator. ADI add immediate to accumulator. Opcode ADI operand 8-bit data bytes 2 M cycles 2 T states 70. Description: the 8-bit data operand is added to the contents of the accumulator. The result is placed in the accumulator. Flags: all flags are modified to reflect the result of the addition. SBB subtract source and borrow from accumulator. SBB opcode operand R bar M bytes 1 M cycles 1 by 2 40 states bar 70 states. Description: the contents of the operand register memory and the borrow flags are subtracted from the contents to the accumulator, and the result is placed in the accumulator. SUB subtract register or memory from accumulator. SUB R bar M 1 by 2 40 bar 70. The contents of the register or the memory location specified by the operand are subtracted from the contents of the accumulator. The result is placed in the accumulator. This SBI subtract immediate with borrow. SBI 8-bit data bytes 2 M cycles 2 T states 70. The 8-bit data operand and the borrow are subtracted from the contents of the accumulator, and the result is placed in the accumulator. SUI subtract immediate from accumulator. SUI 8-bit data bytes 2 M cycles 2 70 states 70. Description: the 8-bit data, the operand is subtracted from the contents of the accumulator. The result is placed in the accumulator. INR increment contents of register or memory by 1. Opcode INR operand R bar M bytes 1 M cycles 1 by 3 T states 4 T bar 10 T. Description: the contents of the designated register memory is incremented by 1. The result is stored in the SAM space. DCR decrement source by 1. DCR R bar M bytes 1 M cycles 1 by 3 T states 4 T bar 10 T. Description: the contents of the designated register memory is decremented by 1. Result is stored in the same place. In INR and DCR operations of except carry, all flags are affected. INX increment register pair by 1. INX operand RP bytes 1 M cycles 1 T state 60. The contents of the specified register pair are incremented by 1. The instruction use the contents of the two registers as an 16-bit number. DCX decrement register pair by 1. Opcode DCX operand RP bytes 1 M cycles 1 T state 60. Description: the contents of the specified register pair are decremented by 1. This instruction uses the contents of the two registers as a 16-bit number. Flags: no flags are affected for INX and DCX. DAA decimal adjust accumulator. Opcode DAA operand none bytes 1 M cycles 1 T states 40. Description: if the value of the low order 4 bits D0 to D3 in the accumulator is greater than 9, or if AC flag is set to the instruction add 606 to the low order of 4 bits. If the value of the high order 4 bits D4 to D7 in the accumulator is greater than 9, or if the carry flag is set, the instruction add 6 to 60 to the high order 4 bits. S, Z, AC, P, CY flags are altered to reflect the results of the operation. DAD add register pair to H and L registers. Opcode DAD operand RP bytes 1 M cycles 3 T states 10 T states. The 16-bit contents of the specified register pair are added to the contents of the HL register, and the sum is saved in the HL register. The contents of the source register pair are not altered. If the result is larger than 16 bits, the CY flag is set. No other flags are affected.